do this. Divide array into equal pairs. You're given an integer array nums consisting of 2 times n integers. You need to divide nums into n pairs such that each element belongs into exactly one pair. Okay, interesting. The elements present in a pair are equal. You divide nums into n pairs. Each element exactly. Okay. So like turn true if nums can be divided to n pairs, otherwise return false. Okay, huh. So like there's 2 3s, there's 4 2s, so you should be able to divide it into pairs. 1 2 3 4, you can't divide them into 2 pairs. Seems simple enough. So first idea would just be to do a count of all the like a frequency count of all the values, and if the frequency at which a value occurs is even, then it should be pairable. Is there a better way? So the numbers themselves are between 1 and 500. So I think, all right, let's do the count first. So in Python, n is going to be the length of nums. Well, technically this is going to be n is the length of nums, but here it's considering this 2 times n, but whatever. If we just use counter to get the counts for this array, then for each value in counts. So counts, when you use counter, it gives you a dictionary, turns dictionary of value frequency. So for instance, counter will give you a dictionary where there's 3, which has about 3 is the value and frequency is 2, and then 2 is the value and frequency is 4. So here, if we go through every value and so for every value in counts, if the frequency of that value, if counts at value mod 2 is equal to 0, no, is equal to 1 if it's unpairable, return false, otherwise return true outside the loop. Should be pretty fast. Alright, pretty fast. I think another way of doing this might be just to have an array of booleans. Yeah, an array of booleans. So, let's actually, okay, the memory usage wasn't that bad. What if I did something like, this is using dictionary. Solution using dictionary. And then if I just use an array of values, so the length is even. Okay. Let's say we have a frequency dictionary. We have a frequency dictionary. That is 501. So for every value in nums, frequency dictionary for that value. How is this any different than using counts? I guess using counter you have a hash map. With this one you have a hard code array. Maybe this is faster. And then maybe instead of doing plus equals 1, I do equals 1 minus that frequency value. So it'll start out with 0, and then the first time it sees it becomes 1, next time it sees 0. So in the end, it'll become like 0 if it's even. And then for every value, for every value in the range of 1 to range 500, 1, if frequency of that value is odd, return false. Otherwise, return true. This should still work. But is it any more? Is it better than using the counter? Not really. What other optimizations are there here? Is it possible to use a set? Maybe if you use a set. Okay, so this is the frequency approach. Hard code frequency array. Dictionary is technically a hash map. Okay, let's do the hard code frequency array, and let's do the set. So we have a set of values, and then value set. It's a set. And for every value in mouse, if the value is the value set, then how is this any better? Value set dot remove the value, else value set dot add the value, and then you just return whether or not there's anything that's in there. Return the length of value set. So if there's anything in there, then it's not divisible. Length of value set not equal to, so if it is pairable, then the length of value set should equal 0. I think it's backwards actually. The length of value should equal 0. That didn't prove that at all. We can just slow it down. A lot of if statements. It's pairable. Each element belongs to the one pair. I mean, this is just the most straightforward way, just using a counter dictionary. Is there a faster way? Faster way? Alright. Here, so I mean, it's pretty self-explanatory, the how it works, but so time complexity for this one is just going to be O of n. There's, you go through each value once in the array. You do like, one calculation. So there's basically size of array determines how many calculations you do, so n the size of array is going to be n time. And then space complexity should be, well, you're using a hash map. With the dictionary, each entry takes some space, and there's n entries, so of n as well. If you use the array method, it's also of n. Well, actually, if you use the array method, if you use the array method, actually, how would you consider this? Sorry, this is going to be O of k, where k is range of values. Is that correct? Yeah. So, is that correct? Or is it O of n? You have, if they're generally unique values, then k is equivalent to, no, not k is not this. It's O of n, because if the range of values was like a million, it's not like 500 entries is going to be a million size hash map. Yeah. So the place complexity here is O of n, where each element pretty much has its own pairing in the counter. So I feel that's not quite correct though. O of n usually, but here, since values are in limited range, I think it's actually something like maybe O of the minimum of n and k. Because let's say you had 5 entries, right? They're generally going to be pretty small. They're generally going to be unique, so therefore it's going to take five entries into your dictionary. But if you had, let's say, 1,000 entries, and all of them are going to be something between 1 and 500, then the number of values is still going to be up to the number of entries is going to be 500, like, or up to 500. Like, values are not going to be past that. But the frequency might be higher, but the frequency doesn't really matter. It's just the number of new entries. Yeah, so it's O of minimum and k. Okay. Hash map is O of n usually, as each entry takes space. So another way of solving this. Each element belongs to exactly one pair. So what if you each number that you see, you increase each number that you see, if it's a unique value, three, 2, 2, 2, 2. Each number that you see, if it's a unique value, then you increment something. If it's something you've previously seen, then you decrement. Doesn't work. Two, 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 two. Let's take the frequency. And just take the frequency, which should be pretty darn fast. And then we have to do for each value frequency. This actually make a difference. Let's see, I think it's for each value frequency and counts.items. Sorry. Oops. Fast. It's the same thing. It's less memory efficient because I think this thing creates tuples. Alright, what is the best way actually on this? Collections.counters. That's the same thing I did. Oh, they didn't use they didn't actually use n. I guess I didn't use that either. Each value set value. Is it just the fact that I had the extra call? I don't know. Somehow this thing ran slightly faster than something that. Oh, they iterate through the values. Counts.values. I guess that. So actually, so values, I guess, only how you say this is key frequency, where the frequency is the value. But you actually go through the frequency, say the frequency. Interesting. Okay, so if you want to be super efficient about it, you just pick the extremely precise way of iterating through that set of things. So you use counts.keys if you want to go through just the keys of your, like the unique values of your numbers. You go counts.values if you just care about the frequencies involved. And then maybe you just use counts.items if you care about both things, the unique numbers and frequency. But, okay.